Hello everyone. Today we're going to be solving a dynamics problem. So let's read it. Block A has a mass of 5 kilograms and block B has a mass of 8 kilograms. Block A and the incline has a coefficient of kinetic friction of 0.3 and a coefficient of static friction of 0.4. Block A is sliding down the incline even though someone is pulling horizontally with a force with magnitude 50 newtons, as shown. Draw a free body diagram for both blocks and provide your coordinate system. Find the magnitude and direction of block B's acceleration and magnitude of the rope's tension. Explain block B's motion, that is, in which direction it is traveling and is it speeding up or slowing down. So, let's start with part A. I'm just going to move out the way. I'm going to change the color. So, part A. Let's draw the free body diagrams for A. Let's start with A. So I'm going to make it a inclined free body diagram because A is on an incline. So whenever the mass is on an incline, you want to make it into an inclined body diagram. So that's what I'm doing right now. Right? Now we have to put the force. So I'm going to put weight here. So it's going to be the weight of A. Now the angle here is, since let's say we imagine it as if we put let's say we put like an axis here, the angle here would be 30 as it is written. So if we were to tilt this by 30, it means that the angle, so if we were to tilt this by 30, so it'd be something like this, the angle here would be 30, that's what it means. But this angle over here would be 90 from here to here, which means that this small angle would be equal to 90 minus 30. It would be, sorry, it wouldn't be from there to there. It would be from here to here, just that. That part would be 90. And all of it will be 180. So it would be, so this one, because this is all of it 90 as well, because it's an axis. So here it would be 60, this would be 60. And since this is 90 degrees, this would just be 90 minus 60, which is 30 degrees. But once you do these a lot, you don't even need to do that. It just comes naturally. So now we that. Now this will be weight of A, cosine of 30. This would be weight of A sine of 30. Now that's done for the weight. Let's do the P. So just want to remake that. All right, that's P. Actually, I'm going to make it dotted because it's not like an X or a Y force, it's just sum of forces. So this is P. And I'm just going to write that it's 50 newtons, so I'm going to put it in parentheses. And let's write this angle. This angle is, we have to determine it. So let's see what it is. If we have, okay, so we have this over here. It's a bit too slanted. Let's say we have this, and then we have the P here. Now, if it wouldn't be inclined, the angle would be 0. And so we inclined it. We inclined it by how much? We inclined it by 30. So this means this angle here is 30. So we can erase all that. This was just to find the angle. All right. So this is 30 again. This would be, oops, I'm going to make it a straight line. This would be P cos of 30. And I'm also going to put it in the y, so this would be P sine of 30. All right, now we also have the normal force. So normal force is always perpendicular to the floor or whatever it's contact with, so that's normal. I'm just going to make it normal of A, so NA. There's also tension, we can't forget that. So there's tension here. Block A is sliding down the incline, even though someone is pulling horizontally with force with magnitude P equal 50. So it's sliding down the incline. So this means that there is a frictional force. It's also written that there's frictional force, kinetic friction. So this means it's kinetic frictional force. So it would be kinetic frictional force is always, in this case, it would be opposite to the way it's sliding down. So it's currently sliding down. So the force of friction will be the opposite. So it's be towards up the incline. So I'm going to put it here. Okay, we'll put it here. This is Fk. And that is it, I believe. But first, we have to assume a direction for acceleration, just so we can do this problem. And I'm going to assume that it's down the incline. If we were wrong, then it just means that our final forces are going to be like negative, and that's fine. It just means that we were wrong. But if they're positive, it means that the acceleration is right, the direction of the acceleration. So let's do that same thing for B, except B is pretty easy. It's just gravity and tension. So let's see. Now, if we assume that acceleration is going down, it means that B is also going accelerating downwards. So I'm just going to write it now. That's acceleration. So this means we also always put the acceleration in the same direction as our axes. So our axis is always the same direction. So a positive y for acceleration here. We have the weight of B, and we have tension. All right, so that is it. So we have to draw a free bar. That was done. And find the magnitude and direction of block B's acceleration and the magnitude of the rope's tension. So that's what our equations. I'm going to write them over here. So we'll do the equations for A first. So let's do forces in X first. So sum of forces in X is equal to weight of A, sine of 30, plus tension T, minus kinetic friction, minus P cos of 30. And that is it for the X. Now, it's accelerating, so it's not equal to 0, but it's equal to mass of A times acceleration. Now let's do that for Y. So in Y we have NA. That's it. So I'm just going to rewrite it. NA minus weight of A cosine of 30 minus P sine of 30. And that's equal to 0 because it's not accelerating in the right direction. So that is it, I believe. Yeah, for A. Now let's do for B. So sum of forces in X. There's no forces in X, so this is nothing there. So just do Y. So it is weight of B minus T, and that's equal to mass of B times acceleration. All right, so now we have to find where we're searching for the magnitude and direction of block B's acceleration and the magnitude of the rope's tension. So let's see what we have. Do we know the weight? Okay, so let's say in the first equation, we know the weight. We don't know the tension. We know the frictional force. Technically, we know the frictional force. And P, we have it, but we don't have the acceleration. So this one has two unknowns. Let's look at the other one. We don't have normal force. We have the weight, and we have P. So we can find normal force, which will help us to find kinetic energy, but it's kinetic friction, which technically helps us, but it still leaves two variables. And let's look at the third one. So we have the weight. We do have that. We don't have the tension, but we have the acceleration. So this means I'm thinking of making a substitution between these two because there's two variables, two unknowns. And that's what we're going to do later. But first, let's find the normal force so we can find the kinetic frictional force. So that's what we're going to do. All right, so let's solve that equation. Just going to find that over here. And so I'm just going to bring those two to the other side is equal to weight of A cosine of 30 plus P sine of 30. And normal force of A is equal to weight of A. So A is, what is the mass of A? I forgot. 5 kilos, so that's 5 times 9.8. 9.8 cosine of 30 plus P sine of 30. P is 50, so 50 sine of 30. Let's calculate that. 5 times 9.8 cosine of 30 plus 50 sine of 30. That would give us 67.44 Newton. So that's normal force. So now let's find the kinetic frictional force. So 0.3. So kinetic frictional force, let's write the equation. That's equal to mu k, so the coefficient, times the normal force. So this is 0.3 that they gave us, times 67.44 newtons, and that's 20.23 newtons. All right. Now let's work with those two equations that we have. So what I'm going to do is instead of we could put this in a system of equations, isolate A in this equation and plug it back in. But I'm going to do a simpler way, is just to make it as one system. So we're going to, oh wait, actually we cannot do that because they're not the same in the same direction. So can we do that actually? Yes, actually we can. So what I'm going to do is add those two together, fx and fy. Or you could also isolate A in here and then plug it back in to here. But I guess we're going to do both ways, and they should both work. So that's what we're going to do. So this is 20.23. Okay. So first method we're going to do is we're going to addition them. So we're going to add those and act as if there's one system. So let me just move it over here. So we're going to add sum of forces for A and sum of forces for Y. So that would make it weight of A sine of 30 plus T minus Fk minus P cosine of 30. And then let's add the forces from Y. So that's plus weight of B minus C is equal to MB times A. Now you'll notice that the tensions cancel. So the tensions cancel. And that makes it so we can solve this for A. Oh, I forgot to add MB. So this is MBA plus MAA. Mass of A times acceleration plus mass of B times acceleration. So weight of A times sine. So let's write this again. WA sine 30 minus Fk minus P cosine 30 plus weight of B is equal to, and then I'm going to just factorize this, so MB plus MA. All right, now let's calculate that. So weight of A sine of 30, so weight of A is, that's 5 times 9.8 sine of 30, and then Fk is 20.23, is 20.23 minus 50 cosine of 30. and then plus weight of B. B is 8 kilos, so plus 8 times 9.8. So that leaves us with, this is 39.37 newtons is equal to A, and then I'm just going to replace, so that's 8 plus 5. All right, so let's divide by 8 plus 5, so by 13. So 39 divided by 39.37 divided by 13. That's 3.03 meters per second squared is equal to A. Now, that works, this method, but let's also do the other method of isolating A in one equation and plugging it back in to the other. So that's what we're going to do. Now, I'm going to isolate A in the B equation, so just divide by mass of B over MB. That gives us A. And then we could plug it back into equation A. So this equation, I'm just going to copy it. Right over here, copy all that. Oops. Forgot to copy that, okay. All right, we're gonna copy that, paste it over here. Oh boy. Just gonna paste that. Great, okay, no. Paste. No. Trying to move it. Okay, there it is. Okay, so let's move it down. There it is. So let's isolate. So this is, we'll plug that here, over here. Want to plug that here. So this is WA sine of 30 plus T minus force kinetic minus P cosine of 30 is equal to MA, and then this is weight of B minus T over mass of B. Right, so now let's plug all the variables that we know so we can simplify this. So weight of A sine of 30, so that's 5 times 9.8 sine of 30. So this is 24.5, so 24.5 plus T, we don't really know that, minus kinetic friction was 20.23. And then that's 50 times cosine of 30, so that's minus 43.30. And that equal to mass of A, so that's 5 times weight of B, which is 8 times 9.8, so that's 78.4 minus T over 8, so that's the mass of B. All right, so let's add and subtract everything that we have. 24.5 plus minus 20.23 minus 43.30. That's minus 39.03 plus T is equal to, and then we'll just multiply that, so that's 0.625 times 78.4 minus T. Now we're gonna subtract that again, multiply that, so that's minus 39.03 plus T, and that's equal to 0.625 times 78.4, that's 49, and then that's 0.625 T. Now I'm going to subtract 49 to the other side, so negative 39.03 minus 49, that is negative 88.03, and bring the T to the other side, so negative 0.625 minus 1, that would be minus 1.625 T. And that gives us t to be, so you have to divide by negative 1.625. So negative 88.03 divided by negative 1.625. That gives us t equal 54.17 newtons. Now I just realized we calculated tension in this one, but if we got to calculate tension in the other one, so we found acceleration to be 3.03. So we can actually plug it back into any equation now that we have acceleration. So let's see, if we plug 3.03 into here, let's see what tension it gives us. So I'm just gonna do that. So weight of B is 9.8 times 8, and then that would be 8 times 2.03, and so that minus that. So 78.4 minus 24.4 gives us 54.16, which is exactly the same as that one. So if we plug that back in here, it gives us t is equal to 54.17, but if you round up 16. So that's it. There are both ways are good to do. It really just depends how you like it. You can isolate in one equation, substitute into the other, or you can act it as a system and just add all the forces so that the tension would cancel out, and then you can plug back. So that's how you do it. Now we can go for problem C. Explain block B's motion, that is in which direction it is traveling and it is speeding up or down. Now we realize that all the forces that we got were positive, which means that our assumption of the direction of the acceleration was right. It is going downwards. So since they say here that block A is sliding down the incline, so B is also going down, and the acceleration we know now is downwards, it means that it is accelerating downwards. Now if velocity has the same direction as the acceleration, it means that it is accelerating, it is speeding up. So this is the case because the velocity is downwards, as I said here, sliding down, and the acceleration is also downwards, which we proved now. So this means that it is speeding up, and that's the final answer. So that's pretty much it. If you like these kind of videos, then make sure to like, subscribe. If you leave a comment saying I subscribed, then I'm going to answer all comments. And yeah, that is pretty much it. I'll see you guys next time.